All right. So most of these questions, you did not need the calculator for. So I'll use the calculator when it's necessary. So with the first 4 questions, you are using the table to answer the questions. And the 2 equations that you're also given. If you had wanted to, you could also have found out that m was exponential because it's being multiplied by 2 each time. So you could have found the function that way as well. So 1, h of -1. There are too many people still doing this. What is wrong with that? Olivia, what's wrong with this? What symbol am I missing? What's wrong with this? Yeah.
Oh, you need parentheses.
There are too many people that did not put parentheses around the -1 when they squared it. -1 squared plus 6. This is 7. E of 7 is 2 times 7 plus 4, which is 18. Okay. You gotta remember those parentheses. I've been telling you that since you were 8th graders. M of -2. M of -2 is 1. H of 1 is 1 squared minus 6 times 1, which is -5. Inverse of m of 4 is 0. Inverse of g of 0. There were a couple of different ways you could have done this. I know that the inverse of g was the equation. This was the only time that in the entire test that you actually had to find the inverse equation. So there are 2 different ways you could have done this. G of x could equal 0. Oh, g of x is the equation. 2x plus 4, x is -2. That's one way you could have done it. The other way you could have done it is actually find the inverse of g. X equals 2y plus 4. X minus 4 over 2 equals y. That's the inverse, y. And then you could have plugged 0 into there. 0 minus 4 over 2 gives you -2. Okay, so there are 2 different ways of doing that. This says for function k and f, find the expression for h of x in simplest form. K of, sorry, this means I'm taking k, that quadratic, and plugging into the linear function. 4 times 2x squared minus 3x minus 5 minus 1. If you wrote that, I gave you 1 point. I would not make this a 3-point problem for just writing that. 1 point for that. 1 point for that. 1 point for that. 3 points, 3 steps. 6, I'd have taken 2 answers. I did have a couple of people confuse this 2x minus 4 2 raised to x minus 4 as something linear. If you wrote a linear function, I didn't take any points away. But that is exponential. So the 2 ways you could have done this is h of x could have been 2 raised to the x minus 4, and j of x is 1 over x. You could have done it like that, or you could have done h of x equals 2 raised to the x. And j of x would be 1 over x minus 4. Okay. All right, taking either of those. Number 7, I gave you a function and 4 different transformations. The easiest one to eliminate, because it says an x-axis reflection, was b. The negative on the inside is a y-axis reflection, because that's talking about drawing like this. Horizontal translation of 3 means I'm moving right 3. So that would eliminate C and D. The answer was A. The other thing that would eliminate it is the vertical dilation of 2. When that wouldn't have eliminated anything unless I had put like 1/2 or something like that. And then vertical translation of 1 would eliminate D. So the answer is A. Oops. Are there any questions on the front page? Okay. So it's worth pointing out that up to this point, not a single piece that I used the calculator for. If anything, maybe on number 1. It was your graphing transformation using the absolute value bars. So that original table, 1, 0, 1, right? Because the absolute value of -1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. Then graph the function y equals 1/2 f of x plus 2 minus 1 by identifying the transformations, filling out the tables. Here's the matter of fact. You could have graphed this on your calculator and still gotten points. Math, that's a different function. 0.5, math, absolute value, x plus 2 minus 1, so 6. So even if you hadn't gotten the transformations right, written it down the table, you could have still graphed it. Okay. All right, the transformations are the 1/2, vertical dilation of 1/2. If you just put dilation of 1/2, I took half a point away because that's showing me that you don't know that that one is vertical. Horizontal translation of -2. That's been happening today a little bit. Even if you had put left 2, I was giving you points. And then vertical translation of -1. Even if you put down 1, I was giving you points. Okay. Even if you work backwards, if you had graphed it and worked backwards, you could have done that too. Now, the vertical dilation and the vertical translation affect the y values, right? The stuff on the outside, we've been saying, affect the y values. The stuff on the inside affects the x values. Okay, so -1 will move to -3, -2, -1. And then 1/2 times 1 is 1/2, minus 1 is -1/2. Which means that other one is -1/2. And then 0 cut in half is still 0. Done 1. So the graph looks like this: -3, -1/2, -2, -1, -1, 1/2. Stuff like that. The other thing that you could have tried as well is that thinking about the absolute value function, that 1/2 is the rate of change. So you could have gone up 1 over 2, 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 up 1 over 2. Again, the graphing calculator would have helped as well. Number 9 was exactly like the quiz. x equals log base 2 of 18. That is approximately 4.16993. 4.1699. Number 10. Similar to one on a quiz, a little bit different. Oh, this one I had to make an inverse as well. So find the inverse of the function square root of x plus 2 and determine the restricted domain in the range of the inverse. So x equals square root of y plus 2. X squared cancels the square root, subtract the 2. If you wrote that, 2 points. Okay. Now, I wrote the table just because there was like, sometimes putting a table in is like the easiest way to organize stuff. So I said use the graph of h to help you find the restricted domain in range of the inverse. Okay. So on the calculator, like this, I'll go like that. Okay. I'll zoom out a little bit. So in the calculator, if I typed in the square root of x plus 2, right? Graph. All right. So I see that my domain here is that x is bigger than or equal to -2. And I see that my y values start at 0. And then what do we say about the domain in the range when we go from the function to the inverse? What's the main idea behind an inverse? Whether it's a graph, an equation, a table, what do the x and y's do? Yeah, they flip. So when we flip it here, this is going to be x bigger than or equal to 0. Y is bigger than or equal to -2. That would have given you the other 2 points just for this column. Okay. If you did the first column correctly, that's good. But I was asking for the inverse. I would have done 1 point for the x, 1 point for the y. Okay. So it is important to point out that other than kind of these directions on number 10 and number 9, there wasn't much work you had to do on the calculator. Okay. I have already made the retake. It's very similar to this. I've just kind of changed up some of the functions and some of the numbers and things like that. So, yeah. We will have once we finish our stuff with systems, we will have another quiz. I haven't made the quiz to see what the point distribution is, but yeah. So honestly, there's no group time today, but if you like coming tomorrow, I'm here before school to ask more in-depth questions. That's great. Okay. Are there any questions on this back page? All right. I think that the most difficult problem was probably this last one. All right. All right. Systems. Going back to you. Probably 1, 2, 3. When I printed these off, I had stapled all 13 copies together. I was like, man, that's not what we wanted. Right. So over the next week and a half or so, we are going to talk about systems. And I will continue to have notes different to and all that stuff. Right. Systems. We're looking for this one. And what folks call this. Okay. systems of equations. All right, a system, and like I said, I have a worksheet for that. Okay, we do on one thing. All right, systems of equations. A system is a group of two or more equations, or they could also be defined as functions, with the same variable where the solution is their intersection. You should remember from algebra that we can solve a system of equations by finding where their intersection is. Back then, we took like 4 lessons to learn the different methods. Between today and tomorrow, we're going to review those methods. We can classify systems into consistent systems and inconsistent systems. A consistent system has 2 different types of classifications. You have an independent system that has one solution, and then you have a dependent system that has infinite solutions. What does that tell you about the lines if the solutions are infinite? Yeah.
They're on top of each other.
Yes, they are the same line. As we know, we have standard form, slope-intercept form, and point-slope form. We're not going to see point-slope form as we look at these problems. We will typically see like standard form or slope-intercept or a small variation. An inconsistent system has no solutions. Those are parallel lines. Okay. Well, I'll put this here. Have infinite solutions. Same line. Systems are nice because they just work. Okay. Now, there are a couple different methods that we're going to take a look at as we solve these. Okay. Graphing. The best time to use graphing is when both equations have variables isolated. Okay. So an equation where you have slope-intercept form for both, that would be a good example of where you would use graphing. And the nice thing is we're just using the graphing calculator. So we're going to review how we find the intersections of lines. There is then substitution. If one of the variables in either equation has an isolated variable, we substitute. Another way of thinking about this is you're plugging things in. Okay. So like this would be an example. Y equals 2x plus 3. I would take this expression, 2x plus 3. I would plug it into the y. Okay. Again, one thing that would be important here is parentheses. You can eliminate variables using addition when they have opposite coefficients, because when you add equations together, that will eliminate a variable, or you eliminate using subtraction when they have the same coefficients. Okay. So like here, x plus 4y equals 8, x plus 3y equals 4, we would subtract the equations. And then the last type is using some multiplication. So we use multiplication to create an elimination using addition or elimination using subtraction. Okay? When you can multiply one or both equations so that you can use add or subtract to eliminate. So like here, we can eliminate x by first multiplying it by 2, or you can eliminate y by multiplying the second one by 3. Okay. Sometimes you multiply one, sometimes you multiply by both. Okay. We are doing this lesson today and tomorrow, so I don't anticipate we'll go through all 3 examples. But I think we will at least get through the graphing. Okay. Example 1. Use the graphing calculator to solve the system and then classify it. Okay. Sometimes you might have to rework the equation to see the graphs. Okay. So be mindful of that. That's doing that and that's backwards. Okay. All right. So here are the steps to solve using the calculator. In my y equals, I am going to put in each equation. 3x minus 4, right? And then I will put this in parentheses, 3/4 x minus 2.5. Okay. Right. When you type it in, it can handle decimals, parentheses, fractions, all that good stuff. Now, we don't always know where the intersection is. So which zoom setting is always kind of the one that resets? That resets the screen.
Zoom stat.
Ooh, zoom stat would be if we have some stuff in this statistics piece, like a scatter plot. So it's not going to be that one. And it's worth pointing out that our stat plot is turned off. But that is one that when we model, we use. Yeah.
Zoom.
Ooh, zoom. Doesn't zoom fit the window base? It fits the window based on I think the X values. Does that show us? Oh, see, so this would be one. You could also do zoom 6, zoom stat, or zoom standard. All right. So there is my intersection. Number 5. Now, so you plug the equations in, second trace, intersect. Then it says first, second, then guess. Here's the nice thing. If you get as close as you can to that intersection, okay, starting on the first curve, you press enter once, 2 times, 3 times. It gives you that intersection, okay? The other thing that's important is that when you move the cursor, you use the left and right arrows. You do not use the up and down. The up and down switches the cursor between the equations, which we don't need to do. The reason you're using the left and right is because it is changing the x values, because that's what you're plugging in, and those are like horizontal values. Okay. Did anybody's graph not look like this? Yeah. But you take it. Oh, you have more than one. Oh. Oh, we do.
So how do you move the cursor in a way that stays on the line?
The nice thing is that when you do the second trace intersection, when you move the cursor to the right and to the left, it will only stay on the line. When you do trace, or if you're just not in any of the modes, you can move the cursor. You can move the cursor just across the graph. But yeah. Oh, whoops. Yep. So here, my answer is 2/3 -2. Oh, 2/3, not negative. 2/3 -2. Yeah.
Mine wasn't as vertical or something.
Did you have the same window, or is your window just a little bit different?
I don't think so. It's a lot.
Oh, it's just because you're more in the It's just because your settings a little bit different.
Oh.
Yeah.
My calculator says no.
What? Because you have the bottom. Your calculator's last time. Right. So perfect. 30 minutes. It's fine. I'll stop this.